Thank you for joining me again. This is another video on the quadratic formula. And in this case, this video, we will be looking at the discriminant of the quadratic formula. So if you haven't seen the video about how to derive the quadratic formula and the video about using the quadratic formula in solving quadratic equations, I recommend that you take a look at those. They are on the same playlist before we actually dive into the discriminant. So as a reminder, if we have a general quadratic equation, it's given by ax squared plus bx plus c equals 0. And using the coefficients a, b, and c, we have the formula for the solutions of this equation. So x here is the solutions. Where we have two solutions, we can have either a plus sign before this square root or a minus sign, right? So we take both the positive and negative solutions of this square root here, and these give us two possible solutions for a quadratic equation. So that is the quadratic formula. Now the question comes up, what is the meaning of b squared minus 4ac? And in particular, we're wondering what happens, for instance, if b squared minus 4ac is a negative number. What do we do with the square root of a negative? What if it's 0? And of course, what happens if it's positive? So in order to understand what happens in every one of these cases, we will look at 3 different examples, each describing a different scenario. And in this first example here, x squared plus 5x plus 4, we will be looking at the case where b squared minus 4ac, the discriminant of the quadratic formula, is positive. So let's look at this in detail. In this case, a equals 1, right? We have just x squared plus 5x, so b equals 5. And c equals 4. So what are our solutions? And we often write these as x1, 2, because we have 2 solutions. Minus b is minus 5, plus minus, right, positive and negative square root of b squared, which is 5 squared, so 25, minus 4 times 1 times 4. So a is 1. And c is 4, and then we divide all this by 2 times a, which is just 2. Now 25 minus 4 times 4 is 25 minus 16, which is 9. So we get x12 equals negative 5 plus minus the square root of 9, divide by 2. Now, the square root of 9 is just 3. So minus 5, negative 5 minus 3 is negative 8 divided by 2 is just negative 4. And the second solution is negative 5 plus 3, which is negative 2, divided by 2 is negative 1. If that was a little bit too quick, stop the video and review that. But basically, these are the 2 solutions. And so when we have 2 solutions, you can see this curve here. This graph is just the graph of this specific function, quadratic function, x squared plus 5x plus 4. And we're looking at when this equals to 0. So we're looking at the 2 points where this graph cuts through the x-axis or the y equals 0 plane. So we're looking at the 2 solutions for the quadratic equations, which are also given by the intersection of the graph of the function with the x-axis. And you can see that when we have 2 solutions, this parabola that is given by the quadratic function intersects the axis in 2 places. So this was the case where the value of the expression inside our quadratic formula, here inside the root, was positive. Okay? Now what happens in this second example, x squared plus 2x plus 1 equals 0. In this case, our a is 1, our b is 2, and our c is 1. And again, we can look at our solutions. We have x1, 2 equals minus b, so that's minus 2, plus minus square root of b squared is 4, minus 4 times 1 times 1. In this case, a is 1 and c is 1, right? And then we divide it by 2a, which is just 2. So now we have 4 in this under the square root. We have 4 minus 4, which is just 0. So basically the square root of 0. So x12 equals negative 2 plus minus 0 divided by 2. But plus 0 or minus 0 are the same. And so in this case, we don't have two solutions. We basically have just a single solution. The solution x equals negative 1. And as you can see in this curve here, which is the graph of this function, x squared plus 2x plus 1, the graph touches the x-axis at one point. So when we draw the graph of the function, we will see that we really do only get one solution. And you can see that because the graph is crossing the x-axis at only one point. And x-axis is exactly when the function equals 0. So this is what happens when we have a discriminant that is exactly 0. We only have one root for the equation. So here we have one root, and in the first case we had two roots. Okay, so now I'm sure you can guess what the third example is going to look at. Let's look at this example, x squared plus 2x plus 3 equals 0. So again, we have a equals 1, b equals 2, and c equals 3. What are our solutions? We have x12 equals, again, minus b, so that's minus 2, plus minus the square root of 2 squared, which is 4, minus 4 times 1 times 3, divide by 2a, which is just 2. So let's write that again. x12 equals minus 2, negative 2, plus minus the square root of. So we have 4 minus 4 times 3, which is 12. So that gives us negative 8 divided by 2. Now, negative 8 does not have any roots, right? We know that no number squared will give us a negative, and therefore we don't have any solutions for this equation, right? We can't find any real solutions. What does that mean? There are no real numbers, right? Any number between negative and infinity squared will not give a result that is negative 8. So when we look now at this curve here, right, this is the graph of this function, x squared plus 2x plus 3. And here we have the x-axis, right? So this is where y equals 0. We don't have any solutions. The graph does not intersect the x-axis at any point. It is raised above it. We could also have a parabola that goes underneath and doesn't cross it. This is a positive and upward facing parabola, but we could have the inverse as well. The important thing is that in no point on the x-axis does this curve y equals x squared plus 2x plus 3 ever intersect the x-axis. So in this case, there are no roots. Okay, so no solutions for the quadratic equation x squared plus 2x plus 3 equals 0. So sometimes when we're not sure if we're going to have a solution or not, it makes sense to just look at that square root and see if we will be able to cross and intersect the x-axis. So thanks for joining me. Again, if this video was helpful, please hit the like button. If you haven't had a chance to look at the other videos about the quadratic equation and the quadratic formula, please take a look at those. It'll help in understanding this video as well. Thank you, and see you next time.